Hi, welcome to Math for All, where everyone can learn more about math. We have been studying all about lines. Today is all about linear word problems. Many word problems lend themselves to linear thinking, and there are numerous questions that can be asked related to linear equations. There are three main examples of linear word problems: constant increase and decrease situations, determining a rate of change, and modeling with direct variation. I'll go over these three that you may see in your homework and on standardized tests. Testers love these because they can be relevant to real life. Linear equations, by definition, are constant increase or decrease situations, and many have real-life applications such as saving or spending the same amount of money each week, emptying a pool at a constant amount per minute, and seeing how far you drive after a certain amount of time, assuming that you stay the same speed. Here's a specific example. What is the equation that gives a worker's total bill if he charges $80 for the call plus $50 per hour? His bill sounds like $80 plus $50, but that per hour means that it changes based on how long he was working. So the bill would be $80 plus $50 times H, or however long he took to do the work. With the equation, we can see that the initial rate is $80 and the variable rate, or the slope, is $50 per hour. We can also plot this on a graph. The y-axis is going to be the total amount paid, and the x-axis will be how many hours he spends on my job. If I flip the numbers around in the equation that we came up with to $50 H times $80, you will see that it's in y equals mx plus b form. The y-intercept is $80. At time 0, I pay $80 because he showed up. It just goes up from there. For every hour, it goes up $50 like this. Hopefully the job doesn't take too long. Next up are questions related to rate of change. You could be given a data table and asked a question like this. What is the rate of change in domestic coffee consumption between the beginning of 2015 and the beginning of 2020? It sounds like a lot of fancy, smart words and really complicated, but do not fear. Rate of change is another phrase for slope. We know that slope is rise over run, or the change of y's over the change in x's, and the x's are almost always time. We'll take 2 points off of this chart. When they say beginning of 2015, I'll use the data from 2014 to 2015, where it's 23.58. Then the other point is 2019 to 2020, and its value is 26.7. Now we just use the slope formula, do math, and give units. 26.7 minus 23.58 on the top, for an answer of 3.12. And then 2020 minus 2015 on the bottom, for an answer of 5. 3.12 divided by 5 indicates an increase of 0.624 million 60 kilogram bags of coffee per year. If we had a negative slope, it would mean that the coffee consumption was going down. Our last example is something called direct variation. It can also be called a direct proportion. It really means that we have a line with a slope, but the y-intercept is 0. The form of these lines are y equals kx. Notice that the k is really the slope, and there's no plus b. Some examples of real-life direct variation examples are how much you would earn if you made $11 per hour and worked H hours. How tall would a tree be after a certain number of years if it grows a ½ inch per year? Or how far you have gone if you travel at a constant 30 miles per hour. Here's an example. How far you travel is a direct variation of the time you drive. If I went 800 miles in 12 hours and 15 minutes, what is K? And what does that K represent? First, we set up the direct variation. Don't get bogged down in the numbers just yet. How far you travel means D for distance equals the direct variation of the time you drive turns into K times time of T. D equals KT. Now that we have that set up nicely, it's time to deal with the numbers given. 800 miles is the distance. T is 12 hours 15 minutes or 12.25 hours. Now we can solve for K. Divide both sides by 12.25. 800 divided by 12.25 is 65.3. So the K equals 65.3. In the context of this question, K has to be the speed the vehicle is moving. There is an important formula that you must remember. Distance equals rate, or your speed, times time, which is a fine example of direct variation. They could take this a step further and now ask you how long would it take that same vehicle to travel 250 miles. Don't lose focus. Let's do it. We'll keep our same formula. D equals KT. The number of miles equals K times time. We figured out that K equals 65.3. And then they tell us that it goes 250 miles now, and we're looking for T. So 250 equals 65.3 times T. 250 divided by 65.3 equals about 3.8 hours. See how a lot of questions and information can be asked from one measly word problem? Congratulations on learning more about linear word problems. This should really help you on standardized tests, as I see these all over the place on practice tests. Now that you've proven yourself to be an excellent learner, please come over to my website, MathforAll.net, watch more videos, and learn more and more about math.